I'm Dr. Piers, and welcome to this video on how to plot error bars that represent the standard error of the mean on your graphs. So before I show you that, I want to just show you how the data that we're going to use, how that was generated quickly. And it's based on an experiment that involves mixing yeast with a solution called sodium alginate. And if you take those together, mix them up, and then put them dropwise into a solution of calcium chloride, what will happen is you will form these yeast spheres. So it's sodium alginate that is encapsulating a bunch of yeast. And if you take those yeast spheres and drop them into a solution of hydrogen peroxide, what will happen is the catalase in the yeast will start to react with the hydrogen peroxide and produce oxygen as a byproduct. That oxygen gets caught up in the sodium alginate spheres, and what will happen is those spheres start to rise after a while due to the oxygen that is captured. And what you simply do is measure the time it takes for those particular spheres to rise to the top, and then you have all your data. So what I want to do now is take you over to the spreadsheet, and what we've got here is a number of different temperatures of the hydrogen peroxide and how long it takes the yeast spheres to rise in those different temperatures, 5 trials of each. So the first thing you want to do is you want to calculate a rate of reaction, and again, because you're looking at something qualitative like the spheres rising, you are simply going to calculate that as 1 over the amount of time that it took. Okay. And so there's the rate of reaction for trial number 1. And using the fill option of Excel, you can simply fill that over, and then you can fill it down. And voila, you've got all your rate of reactions for the various temperatures. Now what you can see down below here is I've got a graph that's kind of pre-made where I'm not, you know how to do that already. So we're going to just plot that data. And to do that, I'm going to actually plot the average. So we'll type in equals average, and we want the average of the 5 trials there. And there we go. Now, in order to plot standard error of the mean, if you recall, you're going to need this equation here. So what you need is the standard deviation of the sample, and you also need the square root of the sample size. So that's all coming up across the top here. So if we calculate the standard deviation, which is STDEV, and you need to tell the computer what you want the standard deviation of, and so I want these 5 trials. Again, don't include the average in that. And there you go. The sample number is just, in this case, it's 5. We could do that. And then the square root of the sample, again, you can punch that into your calculator, or you can ask the computer to do it by simply typing in equals SQRT. And then again, you tell the computer what do you want the square root of, and we want the square root of that one there. And there we go. And then finally we come to this last column, which is we're going to calculate 2 times the standard error mean. Okay, so again, we've got our standard deviation now over here. We've got our square root of the sample size here, so we can calculate this fairly easily by simply going equals 2 times the standard deviation divided by the square root of the sample. And there it is. Okay, so again, utilize the functions of the spreadsheet to make your calculations, because you only have to do all this once, because again, using the fill function, you can fill it all down, and there you have it. Oops, I'll fill it all the way down there. Okay, so now this needs to change. Let me do those, just 5 all the way down. All right, so now you've got all your data, and you can see down below here that I've arranged it so that we've plotted both the temperature on the x-axis and the average rate of reaction on the y-axis. And so the very first thing you need to do, of course, is add a trend line. So if I'm going to do that first, I'm going to choose a polynomial, and I think the best one that looks good is with polynomial 4. So that's a pretty good trend line, looking good. So now we get to the point where we want to add the standard error of the mean error bars. So in order to do this, you simply right click onto one of the data points and you want to format the data series. And there's a lot of different things you can do here, but what we want to do is we want to go to the error bars. Okay. And the first thing it brings up, you can put X error bars or Y error bars. We want Y error bars on here. I would like to display them both above and below the data points, and I like to put caps on my error bars. That's up to you. Okay. Now it's tempting to just click this button down here, but that's not exactly going to get what you think it's going to get. So you need to come down to custom. And you tell the computer that you want to make custom error bars, but then you have to specify the value to that as to which ones you want to use. And you'll see when you click that you get this little box up here. And what you need to tell it, you want to tell the computer that you want these values here, both above and below the line. So by clicking in here, getting rid of that value, and then simply clicking and dragging so that you highlight this, you can see that we want Q3 through Q8 as the representative values for the error bars. And you do the exact same thing down here, get rid of that, and highlight Q3 through Q8. So exactly the same data in both of those. And when you click OK, there you have it. So there's your finished graph with a nice trend line, nice title, everything's there, and now you've got the standard error of the mean error bars. And that is what you can use now to interpret and make conclusions about your data. Thanks for watching.